Hello everyone, welcome to my channel Chemistry is Fun. Today we will study the topic osmosis and osmotic pressure. Now see, it is our common experience that if we dip resins in milk or any milk product like we make kheer, after some time we find that the resin has swollen because the solution which is in the resin is having a higher concentration than that of the concentration outside it. So the solvent molecules will move inside, which leads to the swelling of the resins. A similar situation we can see if we take eggs without shells. Now how to take that eggs without shells? If we take the eggs and dissolve it in, keep it sometime in dilute hydrochloric acid, then the hard shell will be removed by getting dissolved in the acid. So we will get two eggs which are having no shell, that is eggs are without the shell. So these two are the eggs which are without shells. Now one of the eggs we can dip in distilled water, the other one we can keep in a beaker containing saturated salt solution. After some time we find that the egg which was dipped in distilled water, in that water will enter inside the egg fluid. So the flow of water will be towards the egg fluid after some time. And the one which was placed in a salt solution, it will shrink, which is placed in a saturated salt solution, because water comes out, water will come out, water will go outside. So this egg will shrink after some time. So on the basis of this, we can say that whenever there is a semi-permeable membrane placed between a solution and a solvent, we see that the solvent molecules enter the solution and the volume of the solution will increase. So here, and if there are two solutions which are not having equal concentrations, that is the solutions are of unequal concentration and they are separated by a semi-permeable membrane, then the solvent molecules from the solution of lower concentration move towards a solution of higher concentration. So as we see in the second case, the water comes out of the egg because outside the saturated salt solution is present. So water will move out. In the first case, the egg without the shell was kept in distilled water. So the water enters inside the egg fluid. So on the basis of this, we can define osmosis that osmosis is the spontaneous flow of solvent molecules through a semi-permeable membrane from a pure solvent to a solution, otherwise from a dilute to a concentrated solution. So in the first case we find that there is a pure solvent outside, which is distilled water. From here the water moves towards the egg fluid. In the second case, water comes out of the egg fluid because outside solution is saturated. So these both cases exhibit the phenomena of osmosis. Now see, if there is no semi-permeable membrane, here there was a semi-permeable membrane, the membrane which is enclosing the egg fluid, that is the semi-permeable membrane here. In case there is no semi-permeable membrane, in that case there will be flow of that is movement of solvent molecules as well as solute molecules in opposite directions. Then we call it as diffusion. The solute and the solvent molecules, they will flow in opposite directions. But in case of osmosis, there is flow of solvent molecules in one direction only. So this is one major difference between osmosis and diffusion. Second important difference is that in case of osmosis, there should be a semi-permeable membrane. A semi-permeable membrane is required. Now we can do one thing, you see, we can have a setup like this. We can take water in a beaker. This is water which is taken in a beaker. In that we put another container which is having a semi-permeable membrane. Inside that we keep sugar solution. Now we will find that water will flow from the outside beaker towards the sugar solution side because the concentration of the sugar is more, it is more concentrated. It is having concentrated sugar solution. We will find that there will be osmosis and the level of the solution in the glass tube, this is the glass tube, so the level of the solution will rise after some time, that is because of osmosis. And then we find that after a certain amount of time the level will become stationary. So this is the equilibrium state. At this state the hydrostatic pressure of the liquid column balances the tendency which enables the water to pass through the semi-permeable membrane. So this is the semi-permeable membrane I have marked here. Through this water molecules are entering inside. But when equilibrium is reached, that is the level is not rising in this tube as you can see. At equilibrium state the hydrostatic pressure of the liquid column balances the tendency which makes the water molecules to pass through the semi-permeable membrane, means the water molecules are no longer entering inside it. So the level which I have marked here, maximum level, that becomes stationary. So the hydrostatic pressure which has developed because of osmosis is a measure of the osmotic pressure of the solution. So see, this is the hydrostatic pressure and that has developed because of osmosis. So if we can measure this, it will give us a measure of osmotic pressure of the solution as well. So osmotic pressure can be defined as the hydrostatic pressure built up on the solution which will just stop the osmosis. Means we can also define it that because water is trying to enter or towards the higher concentration side, and if we apply some pressure which will stop this osmosis, then that much pressure can be termed as osmotic pressure. At equilibrium, osmotic pressure that is equal to the hydrostatic pressure. So we can also say that pi is equal to H dg. Here H is increase in level in the tube, D is density of the solution, G is acceleration due to gravity. Now osmotic pressure also can be determined by certain methods. One was Berkeley-Hartley's method. In Berkeley-Hartley's method, see, this is the setup I have drawn here in the figure. We can see there will be a porcelain tube which is having copper ferrocyanide membrane, that is the semi-permeable membrane that you can see here. I have marked here in the diagram. There will be a porcelain tube having copper ferrocyanide membrane in the walls, and that will be enclosed in a metallic jacket, means outside there will be a metallic jacket. This tube is fitted with a reservoir of pure solvent. So this is water here, that is the pure solvent. It is connected to a reservoir, and at the other end you can see there is a capillary tube. Now, and the externally, this is the metal jacket. You can see I have marked with blue color this external part, this one. This is the metal jacket. In this there is also an arrangement so that we can apply external pressure. You see marked here. We can apply external pressure whenever required, and that can be measured with the help of a pressure gauge. So the metallic jacket is fitted with an arrangement so that we can apply external pressure, and this can be measured with the help of a pressure gauge. Now how it works? This porcelain tube is filled with pure solvent. Inside you see I have marked here water. That is the porcelain tube that is filled with a pure solvent. Outside metallic jacket is filled with solution. It is labeled here. These two areas you can see, they are filled with solution. Now the level in the capillary tube will move down. See, this is the solvent. It will try to go towards solution side. So the level in the capillary tube should go down. And this happens because of osmosis, because there is a semi-permeable membrane marked here. Now see, we can apply some external pressure on the solution by a piston. See, here one piston is fitted. With the help of this piston, we can apply pressure towards the solution. External pressure can be applied on the solution by the piston so that the level in the capillary remains stationary. So the level in this capillary will be constant, it will be stationary. This pressure gauge reading is recorded, and this is the osmotic pressure of the solution. The pressure gauge reading can be recorded, and this will give us the osmotic pressure of the solution. For this method, there are certain advantages. First is that it is very quick and accurate, and we are not allowing the solvent to move inside into the solution. So the concentration of the solution will not change. The solution concentration does not change as the solvent cannot flow into the solution, and the osmotic pressure is balanced by external pressure, so there is no strain on the membrane. So if we are required to measure high osmotic pressure also, we can use this method because the osmotic pressure is balanced by external pressure. So strain on the membrane will be negligible. This method can be used to measure high osmotic pressure. I hope you all could understand the topic which I discussed today. Thank you all for watching my video. Please subscribe to my channel. Thank you all.